Hey kids, this is going to be a quick description of how to do question A2. Not sure how quick it is, but let's just dive right in and see what's going on. So I have a graph right here. This is the graph of f, and I want to go through and figure out how to calculate g of 2 and g prime of 2. Well, if this is my function g of x, I know that g of 2 is going to equal the integral from -1 to 2 f of t dt. So that means from -1 to 2, I just want to calculate the area under the curve and then go from there. So I have a triangle that's below the x-axis, a triangle that's above the x-axis. So remember that your answer is going to cancel out as far as negative and positive there. So this is just area under the curve. In order to find out g prime of 2, there's a few things that we got to remember. First of all, g of x equals the integral from -1 to x f of t dt. So if I take the derivative of both sides, what that gives me is g prime of x is going to equal, by the second derivative test, f of x. So I know that this is the graph of f. It is also the graph of g prime. So if I'm going through and trying to solve this out, g prime of 2 is going to equal f of 2, and that's just going to be the position on the graph. For letter B, what I want to find is I want to find the average rate of change of g on this interval. Remember, the average rate of change is f of b minus f of a over b minus a. In this case, it's going to be g of 6 minus g of 0 over 6 minus 0. G of 6 is the integral from -1 to 6 of f of t dt. G of 0 is the integral from -1 to 0 of f of t dt. Subtracting those, all over 6. So I'm going to calculate the area under the curve for this, the area under the curve for this, and then divide by 6, and that will be my average rate of change. For letter C, you want to find the x-coordinate of any point of inflection on G. Now remember from earlier, this is the graph of G prime. So I know that when G prime is increasing, okay, I am going to be concave up, and when G prime is decreasing, I am going to be concave down. So if I'm taking a look here, I know that G prime, okay, is G prime is decreasing here, and then it's increasing here. So I get a point of inflection right there because G prime is going from decreasing to increasing. Here, G prime is going from increasing to increasing, so that's not one. And that is where I'm going to stop because I want to go from -2 to 2. There is another point of inflection over here, but it's not in the interval, so I'm not going to worry about it. Here, I want to find the absolute minimum value. So not the x-coordinate, but the actual minimum value from -2 to 6. Now the key word is absolute, and absolute minimums can occur at critical numbers, or they can occur at endpoints. So if I'm going through and just taking a look, remembering that this is the graph of G prime, that this graph is G prime is decreasing, then it's increasing. So G prime is going to be negative, it's going to be negative. But here, G prime goes from negative to positive. So right here is going to be a minimum. Here G prime is positive, G prime is positive, and then suddenly G prime goes from positive to negative. Well, this right here would be a maximum, not a relative minimum. And then I have the endpoint of 6. So my endpoints are going to be -2 and 6, but from -2 the graph is decreasing because G prime is negative. So the only values I really care about are 0 and 6 as far as where a minimum can occur. So I need to figure out G of 0 and I need to figure out G of 6. Now we did figure these out earlier in letter B, so that will help you solve this out. But it's understanding that here throughout this interval, G prime is going to be negative. So that means the function is going down. Here the derivative changes from negative to positive. So that means I get a minimum. So that's a possible place where I get a minimum value. Here G prime is positive, so it's going up. G prime is positive, so it's going up. G prime is negative right here. Going from positive to negative, I get a maximum, and so I got to check the endpoint. So do the calculation, and then the smaller of these two values will be your minimum. And here it is, part E. I want to determine if there is a relative min, relative max, or neither for h at x equals 2. Well, first we got to see what's happening at x equals 2, so let's take a derivative. H prime of x is going to equal first derivative of the second plus second derivative of the first, which is going to be 1. When I plug in 2, I get 2 times G prime of 2 plus G of 2. G of 2, we found this one in part A. G prime of 2, we also found this one in part A. So H prime of 2, when I plug those values in, is going to be 0. So that means x equals 2 is a critical number. Now I don't have a number line to check to the right and left of 2 to see if I'm positive and then negative, or if I am negative and then positive. So I can't really go through and just use a number line. So if I want to determine a relative max or relative min, I have to use the second derivative test. So that means I'm going to take a second derivative, I'm going to plug in 2, and then see if h double prime of 2 is going to be greater than 0, or h double prime of 2 is going to be less than 0. If h double prime of 2 is greater than 0, that's telling me that it's concave up, so it'd be a min. If h double prime of 2 is less than 0, that tells me it's concave down, so it's going to be a max. So take a second derivative. You're going to have to use the chain rule. Again, plug in 2 and see what you get.